Hello everyone, myself Rizwan Hameed. The topic of my discussion for engineering research methods is to develop a welding technique to join dissimilar metals 2.25 chromium 1 steel and ASI 310 stainless steel for refractory applications. These are list of contents through which I will be going on my presentation. So starting with introduction. Why is there a need to join these two dissimilar metals? As it has been clearly visible that many industries now require high temperature furnaces, avionics, automotive application, and to fulfill the demands of these applications, there is a requirement to of capability to withstand high temperatures, and these two dissimilar metals has the property which can be used and make them suitable to use for industrial purposes, such as 2.25 chromium 1 steel is a good heat resistance and also a good corrosion resistance and oxidation resistance. Similarly, ASI 310 stainless steel has a far superior mechanical properties as compared to other metals such as thermal diffusivity, thermal conductivity, heat capacity, and low density. So these all properties are extremely important in the use of industrial hot nature equipment such as boilers, heat exchangers, refractories, and other, etc. Hence, when these two dissimilar metals are joined, they hold a greater significance as these both materials are now have more superior qualities or more superior balancing of mechanical properties as compared to other metals. Hence, to fulfill the demands of these industry applications, these metals need to be joined. So, there were many researchers who have done many welding techniques on dissimilar metals, which have been include spot welding, submerged arc welding, electron beam welding, fusion welding, shielded gas metal arc welding, laser beam welding, friction welding, and electromagnetic and fusion welding. Starting with one of the most innovative and modern welding techniques were discussed were spot welding, submerged arc welding, and electron beam welding. The limitations of these welding techniques were that these were not fully developed, and these techniques are unreliable and desired results are not achieved. Moreover, shielded gas metal arc welding and gas tungsten metal arc welding did provide some enough efficient results and high quality strength of weld joints were created, but there were some impurities in the welded joints, and it was very difficult to remove those impurities using these methods of welding. However, laser beam welding, which was discussed by one end of the journal in M.J. Hameed, his limitation was that there was many intermetallic compounds formed in the final product. Moreover, many of the researchers used friction stir welding to join dissimilar metals. All of them encountered the intermetallic compounds formation problem, but except for one study which was conducted by Watanabe. However, the gas tungsten and shielded metal arc welding is also a valuable technique discussed by researchers and employed in many research journals. The drawbacks of this welding technique is that it doesn't create weaker strength of welds, but parameters are difficult to control. However, the strength of welds are enough, but the parameters are very difficult to control. So overall, the friction stir welding is mostly employed by researchers, and it has very far advantages than other welding techniques, and the results are also very reliable, and strength of specimens of welded are very enough, and high strength welded specimens are created. Furthermore, to analyze the mechanical properties of the weld nuggets, the researchers have used Vickers microhardness test and Charpy notch test. Moreover, to analyze the microstructure of the welded specimen, the scanning electron microscopy and X-ray diffraction method is employed by researchers. Now moving forward to research design. What research question I have been gone through or I have finalized is that I will be using the procedure of friction stir welding to join these two dissimilar metals 2.25 chromium 1 steel and ASI 310 stainless steel, and I'll adjust the welding parameters to get the better quality of weld strength. And it can be seen that the objective of this research is to develop a high-strength weld joints and which can endure high temperatures such as in refractory furnaces. And none of the researchers have used friction stir welding to specifically join these two dissimilar metals. So the related work has been done previously by researchers who have used friction stir welding. For instance, the Watanabe has used friction stir welding to form a butt joint between aluminum plate and mild steel, and he has inspected the effects of pin rotation speed and the position of the pins. The welding parameters that he used in his study was 100 to 1250 mm RPM pin rotation speed and 25 mm per minute welding speed. The advantages of this design was that the pin rotation speed was easy to control. So the welding parameters can be adjusted to create a good strength of welding joint, and there were no intermetallic compounds formed. However, one gap in this design was that the welding can only be performed in clockwise direction. It cannot be performed as a counterclockwise direction. In one of the other research journals incorporated by Onoma to weld magnesium alloy and titanium was friction stir welding method using the probe method. And here he has also created a butt joint on a rectangular plate. The advantages of this design was that high quality joints was created, but the limitation of this design is that it is the first design where the probe is utilized for friction stir welding. Hence, it's very difficult to control the parameters of this design to get a bi-strength welded joint. So in my design, I have chosen friction stir welding to create a butt joint, and I will be using the welding parameters used by Watanabe in his research. There's a rotating speed of pin 100 to 250 RPM and welding speed 25 millimeter per minute. The samples I will be using will have the thickness of 2 mm, 140 mm in length, and 40 mm in width. And before carrying out the experiments, I will do etching and polishing of my samples with emery paper to have uniformity. I'll be using 5 samples with different rotation speeds of pin and welding speeds to get the average result from all samples, and I will compare those results to find the which rotation of pin speed gives the high quality of strength. So the research followed by Watanabe shows that the pin rotation speed of 250 RPM resulted in the optimum weld strength of the joint. So I'll be using different pin speeds such as 100 RPM, 250 RPM, 500 RPM, 1250 RPM, and will analyze which pin speed is much better to create a high strength of weld for my research design. And it has also been seen that if we use higher pin rotation speed, it will not create a better joint and it may break during machining, as it has happened already in Watanabe research. Moreover, to analyze the mechanical properties of in my design, I will be doing Charpy notch test and Vickers micro hardness test, and also tensile shear stress test. To analyze the microstructures of my welded specimens and welded nuggets, I will be doing scanning electron microscopy and X-ray diffraction method. Well, the limitation of this design is that the welding can only be performed in clockwise direction of the pin, as stated by the Watanabe in his research. However, there are many advantages of this research or this design using friction stir welding, such as there will be no intermetallic compounds formed, and I can alter welding parameters to get a desired quality of high strength welded specimen. So in conclusion, I'll conclude by saying that friction stir welding technique has far more superior advantages over other welding techniques, as its parameters are easy to control and can create high strength of weld joints. The disadvantages of it is not very related to the strength of welded joint, and none of the previous researchers have used this technique to join 2.25 1 MO steel to AISI 310 stainless steel. And I can easily say that this welding will give us the much better results than other welding techniques. So these are references that I have used in my presentation. Thank you very much for your time. Thank you.